Okay, welcome back. Here we go. Homework 27. Indefinite integrals and substitution method. This will be our intro to the U substitution. So we are putting lots of tools in our toolkit. Up until this point, we know the integral of x to the n is x to the n plus 1 over n plus 1. So let's add to our plethora of tools that we will have to integrate various functions. So the U substitution, I can tell you, you want to be on the lookout for composite functions. So whenever you see composite functions, that's a clue that U substitution might be a good thing. It doesn't always work, but it's something you want to try. Okay, so what we're going to do is we're going to let U equal this inner piece here, negative 2 plus 3s. Then du would be the du ds, I should say, would be the derivative of this, which would be 3. Now what I'm going to do is sort of cross multiply that ds up there. So therefore du equals 3 ds. Now what you're noticing is that ds matches with ds, and it's kind of like you want to do a replacement and rewrite this integral in terms of u. So I'm going to do a little bit of algebraic manipulation. Divide by 3. Okay, so what we're saying is that ds is basically equal to 1/3 du. So we're going to do a replacement. We're going to replace this ds. Note to self, replace. Replace it with what? With 1/3 du. And we're going to do a total u substitution here. So this would lead us to then the integral of the square root of u times, and then ds is getting replaced with 1/3 du. 1/3 du. Now we know that we can pull this 1/3, this scalar, we can pull that out front. The constant multiple rule, we can pull that out front of the integral. So then we're going to have 1/3 integral square root of u du. And voila, we have performed the u substitution. Now that really means the integral of u to the 1/2 du. Just keep that 1/3 floating out front. Okay, so do the plus 1 rule. So u to the 1/2 or u to the 3/2 plus c, and then we'll have 1/3 times that. So let me say that again. So 1/2 plus 1 is 3/2, and then it's over 3/2. Now that's stylistically, that's awkward, so you want to keep cleaning that up. So now we've got 1/3, 2/3, u to the 3/2 plus c. All right? Keep cleaning. So that's 2/9 u to the 3/2 plus c. So at the very end, though, you can't leave u like that. You know what I mean? You got to go back and store it in. Note to self, go back. Go back and sub whatever u was. Well, from the very get-go, we had let u, right here, equal to negative 2 plus 3s. So let's store that back in. So then we'll have 2/9 negative 2 plus 3s. Whole thing to the 3/2 plus c. Because remember, you want your final answer to be with regard to whatever the original variable was, which was s. So let's grab this. And now, remember, I had pasted in a little cheat sheet answer here. I'm going to copy that down lower. And we'll see how well that matches up with what we just got. And voila. I always like to paste in the answer. 2/9 negative 2 plus 3s to the 3/2 plus c. There we go. We got it. Okay, so, initially a u substitution is kind of awkward, getting it used to it. But we're going to do that over and over again in the hopes that you get used to that. Let's try another. I'll hit pause. Many things in life are awkward until you do them again and again and again. Get better at it. Okay, so if u equals g of x is a differentiable function whose range is an interval I and f is continuous on I, then I like to think of it here, f of g of x, well, that's a composite function. So that's what I've been saying all along. So the substitution rule, you want to be on the lookout for a composite function where particularly is being multiplied by the derivative, or very much related to the derivative of the inner part of that composition. So you'll see that as we do here. So this is a composite function, so is this. And here they're telling us, use the indicated substitution to evaluate the integral. So all right, so we'll let u equal to 3x. Then du dx is equal to 3. Then du is equal to, I'm just going to highlight there, du is equal to 3 dx. Now you can spin that. Divide both sides by 3. You want to isolate dx. So then dx, that basically means that dx can be replaced with 1/3 du. So what I'm going to do is circle that. Take dx, way back in the original, rewrite the original integral with replacing dx with this new expression, 1/3 du. All right, let's try it. So we'd have integral 6, and then we'd have secant u, tangent u, and then we'd have, we would be replacing this dx with 1/3 du. I'm going to squeeze it in right there. Now, like I said, you can clean that up algebraically, like 6 times 1/3 is 2. So let's keep cleaning that up. So we'll have integral 2 secant u tangent u du. Now we luck out. When you integrate secant tangent, it's kind of like give me the function who's that, you know, that's its derivative. So that's clearly secant. So that's going to be, and the 2, you know, you can pull it out. It's just being multiplied. So you can pull it. You could pull that out front of the integral, mentally or physically. So that's going to be secant u plus c. The 2 is just going to stay out front. Okay, and then like I said, at the very end, you want to put, you don't want to leave it in terms of u. You want to put back in what u was. And from the very beginning, we had let u equal to 3x. So put that back in. Plus c. And voila. Okay. So then you see I have the answer here, 2 secant 3x plus c. So now remember that I had to know that the integral of secant tangent is secant. So some of those integrals have to, the trig integrals have to be memorized. Like the integral of cosine is sine type thing. Okay, hope that helps. And I will hit pause and we'll go to the next one. Okay, problem number 3. Evaluate the indefinite integral by using the given substitution to reduce the integral to standard form. Again, it's kind of nice here because we're being told. Initially, you're being told what to do just to get used to it. Then down the road, you're going to have to decide that yourself. But let u equal to 7x, then clearly du dx will equal to 7. Therefore, du will equal 7 dx. Therefore, dx would be du over 7. So that means that we can, note to self, replace. We can replace dx in the original integral with du over 7. All right, let's do that. So integral cos u, now we're replacing dx with du over 7, or if this means 1/7 du. Now keep cleaning. 1/7 you can just pull out front, constant multiple rule. So you have integral cos u du, and then you say, what's the integral of cosine? That means give me the function that's its derivative, that's sine. So it's going to be sine u, the 1/7 just stays out front, plus c. Now you get to there, I'm happy, you just got to remember to put your u back in. So sine, whatever your u was, which from the very beginning we said was 7x, and the 1/7 can float out front. Now there, I'm double happy. Haha. Okay, so now let's check the final answer, which is, I always paste that in just so you have it. It's right here. So sine 7x over 7 plus c. Stylistically have it written a little bit different here. It means the same thing. All right. Hope that helps. And I think maybe we have one more problem. Let's see. Yep, last problem. Okay, so notice that with this one, if we're so used to letting u equal this inner composition, right? But if I let u equal to x minus 12, then du dx is equal to 1. So, du is equal to 1 dx, which doesn't really get you too far. So, that basically tells you can replace dx in the original with du, but, it doesn't get you too far in terms of the rest of the problem. So you have to do a little manipulation here. So notice that substitution is not yet complete because we have not expressed the integrand entirely in terms of u and du. Since we cannot move variables outside the integral sign, we must return to the original substitution and solve for x in terms of u. So I have that hint here. I'm just going to do that for you in real time. Return to the original substitution. So return to u equals x minus 12. And note to self, the trick is isolate x. And you'll get used to some of these manipulations. So then x equals u plus 12. So that means that I can replace, note to self, I can replace x with u plus 12 in the original integral. So with this guy right here. Okay? So let's do that. So then we're going to have integral u plus 12 over root u, square root u du. Okay, now you look at it in that form and you say, well, now what do I do? Now it usually lends itself to algebraic manipulation. So that's the same as u over root u plus 12 over square root u du. So in other words, you can do separation of fractions, sort of, like that. Now keep cleaning. Square root of u, square root of u, that really means u to the 1/2. So you've got u over u to the 1/2 plus 12 over u to the 1/2 du. I would just keep cleaning that up. So let's see, 1 minus 1/2 is 1/2, so you've got integral of u, like use the rules of exponents, so subtract, so 1 minus 1/2 is 1/2. So if u to the 1/2 plus, and use the rules of exponents, you'll see what I do, 12u to the negative 1/2 du. So I just brought this power up and, wrote it as a negative exponent. It's going to make it easier to integrate. Okay, so now we use the little plus 1 rule for this. So 1/2 plus 1 is 1.5, or 3/2. So you have u to the 3/2 over 3/2. This one, negative 1/2 plus 1 is a positive 1/2. So you're going to have u to the 1/2 over 1/2. And then, of course, plus c. So we get there, and I'm pretty happy. Now you just got to store that, got to clean it up, and store the u back in. So u was, what was it, x minus 12. So let's store that back in. So you'd have x minus 12 to the 3/2, and then you're going to have some flipping there that occurs, so 2/3. 12 divided by 1/2 is 12 times 2, which is 24. And then x minus 12 to the 1/2 plus c. So after all that, let's go ahead and see if we got the right answer, because I had clipped it in from the beginning, but I made it really small. Let's paste it in way down here and check ourselves. Let's see, survey says we got this part, and plus c. Yes. So I always like to just clip in the answer key just so we have that. And you can see it done in real time. All right, I think we did it. So I hope, it's going to take practice getting used to a U substitution, obviously. And I'm confident you'll get it. Good luck out there.